So this is the next question that we have, guys. There are three events A, B, and C. A is an independent event of B and C. B and C are mutually exclusive events. The probability of A is given to be 0.2. The probability of B is 0.3. The probability of C is 0.6. And we have to find the probability that none of the three events A, B, C will occur. Okay. So firstly, tell me one thing. What is the difference between mutually exclusive and independent event? So mutually exclusive basically means, for example, there are two events, right? There is one event A and there is another event B. So mutually exclusive means that if event A is happening, then event B cannot happen at the same time. That is what mutually exclusive means. Because, for example, if you take a normal case, right? If, for example, this is A and this is B, this is A, this is B. So there will always be some form of intersection which will be there. So, for example, the formula for this is probability of A or B. The probability of A or B is equals to probability of A plus probability of B minus probability of A intersection B. So this is the formula that comes out in a normal scenario, right? Where probability of A or B means this, basically this entire thing. So probability of A or B is probability of A plus probability of B minus this common part, because the common part is repeated twice. Because when we take A, this common part is there. When we take B, this common part is again there. So basically this common part, right, this get repeated twice. So we remove this once so that we get this entire area, basically. So this is what probability of A or B, or you can say probability of A union B. Both are same things, right? But when two events are mutually exclusive, that means there is no intersection part over there. So probability of A union B becomes probability of A plus probability of B, because in this case probability of A intersection B becomes 0. I hope this makes sense, because in this equation, if we make the 0, it will be probability of A plus probability of B, right? Because in this case there is no intersection part, because this was the intersection part earlier, but in this case there is no intersection. So if I give an example, for example, we roll a die, right? We roll a dice, we can get 1 or 2 or 3 or 4 or 5 or 6, right? But if we get 1, then obviously we cannot get 2 at the same time, right? So those are mutually exclusive events, basically. That if one event is happening, then obviously the second event cannot happen, right? Okay. Now, talking about independent event. So there are two terms, mutually exclusive and independent. What does independent mean? Independent means that there is no dependency. For example, we roll a dice and we roll a coin. For example, we toss a coin. So tossing a coin and rolling a dice are two independent events. They have no relation with each other, right? I mean, if you roll a dice or if you toss a coin, I mean, they have no synergy. There is no relationship. That is why they both are independent events, right? So I hope this should be fundamentally be very clear, right? Okay. So I hope all of this makes pretty good sense, right? So now if we were to look at the question, so we know that B and C are mutually exclusive, right? Which means the probability of B or C, the probability of B or C will be probability of B plus probability of C. Why? Because the intersection part is 0, as I explained before. So what will be this? What is probability of B? The probability of B is 0.3 plus what is probability of C? It is 0.6, right? So this comes out to be 0.9. So this is probability of B or C, right? In the question we are asked, we have to tell none will occur, right? So neither A nor B nor C, right? Okay. So tell me one thing, guys. The probability of B or C is 0.9. That means um, if I were to draw a diagram just to explain you guys, this is B, right? And this is C. I hope this is clear, right? So probability of B or C means this plus this. This is probability of B or C, right? 0.3 plus 0.6. But we want to tell that none will happen. So first let's talk about B or C. So probability that B or C will happen is 0.9. We have to tell that neither B nor C will happen. That means we will have to tell this part, the outside part. We have to tell this part, that neither B nor C. So what will be this part? This part will be the entire thing, which is what? 1 minus these two things, which is 0.9. This gives us 0.1. I hope this makes sense. So this entire thing is 1, right? Minus BC. So minus, we subtract from the entire thing, we subtract this and we subtract this. Therefore, we will get this entire outside part. And what is this plus this? This plus this is 0.9, as we have calculated before. So 1 minus 0.9 is 0.1. So what is 0.1? 0.1 is basically neither B nor C. I hope this should be very clear, right? So probability of neither B nor C, this comes out to be what? 1 minus 0.9, which is 0.1. I hope this should make absolute sense, right? Okay. Now tell me one thing. The probability of A is what? 0.2, right? The probability of A is what? 0.2. So probability of not happening A, like if probability that A will happen is 0.2, then what is the probability that A will not happen? Is 1 minus 0.2, obviously, right? So probability that A will not happen, yep, or probability of not A, basically you can write anything, that is 1 minus 0.2, which is 0.8. I hope this is pretty clear, right? So we have come up with two things till now. Probability of A not happening or A doesn't happen, that is 0.8. Probability that neither B nor C happens is 0.1, right? Okay. Now tell me one more thing. Because we know that A is independent of B and C. A is independent of B and C, right? Sorry. So this is probability of neither A nor B, right? So we are given that A is independent of B and C, right? So probability of A, so probability of neither A and probability of neither B nor C, right? This will be what? This will be 0.8 into 0.1. I hope this is clear. Uh, okay, before that, I would just like to tell you that if two events are independent, for example, there is an event A, there is an event B, right? If two events are independent, then the probability of A and B is probability of A into probability of B, right? If two events are independent, then the combined probability basically is the probability of the first into the probability of the second. Similarly, we know that A is independent of this, right? So, probability of neither A, which is 0.8, and probability of neither this, which is 0.1. If we want to calculate the combined probability, that will be 0.8 into 0.1. So that becomes how much? 0.008. And what is 0.008? Sorry, 0.08, right? 0.08, right? Okay. And what is this? This basically means probability neither A nor B nor C. This is what? Probability of neither A nor B nor C. This is 0.008. I hope this kind of makes sense. Um, I don't think there should be any confusion. So what we did was that I explained B and C are mutually exclusive. What mutually exclusive means, right? When there is no intersection between two events, that is mutually exclusive, right? So probability of B or C becomes probability of B plus probability of C, right? And if we want to calculate the negation, that means if we want to calculate that none of the event occurs, we do 1 minus that. So we get 0.1. Similarly, we know probability of A is 0.2. So probability that A will not happen becomes 1 minus 0.2, which is 0.8. Now we know that because the event A and this event B and C, sorry, this is B and C, right? Probability neither B nor C. So if A is independent of this means the combined probability will be this into this. So not A is 0.8, neither B nor C is 0.1. So neither A nor B nor C will be 0.8 into 0.1, which is 0.08. So I hope this should be clear. Once you practice this on your own, you will get much better clarity. But this is all the question was asking for. And I think if you do this question like with good concepts and understanding it properly, you will not have any problems. So I hope this should be clear.